Okay, so going back to this example again, if I'm at 2, 4 right here for my original point, and I want to increase this by a scale factor of 4, I'll multiply 2 times 4, and I'll multiply 4 times 4. So my transformed image, my enlarged point, I guess I should say, the distance from the center, is at 8, 16. Okay, so it would be somewhere over here, 8 and 16 way up there. Okay, so that makes sense. I'm this far away from the center. I multiply everything by 4. Now I'm 4 times away from the center up there. So that's an example. Scale factor 4xy, 4 times x, 4 times y. Now what if the center is not at the origin? What if I have a center that is displaced? Let's say that, well, I don't have enough room on that. Let's say that my center is at 2, 6. Okay, and I want to scale the point -3, 7 with a scale factor of 2. Okay, yeah, with a scale factor of 2. Okay, let me actually quickly make a graph here. Let's quick graph here. If I have this graph, all right, my center is at 2, 6. 2, 6. I have this point here, -3, 7. And I want to draw it with a scale factor of 2. So in other words, I want to go 2 times further away from the center. So obviously, you know, the point will probably be somewhere around here. But mathematically speaking, if it wasn't that simple, how could I end up graphing these? Okay, here's what we're going to do. We are going, because here's what we can't do, actually. Here's why it becomes tricky. I can't just say, you know, like this one, I can't just take my scale factor and multiply it by these points. What if I took -3, 7 and multiplied it by a scale factor of 2 here? Then I'd get -6, 14. And is that a similar point that's the distance away from the center? No, our point's somewhere over here. So we need to treat this right here like we are at the origin with our center. So here's what we have to do. We have to translate everything. Well, I guess that didn't really come through right, but we have to translate everything as if we're at the center. Okay, so how did we translate that? I guess that's the important question there. If we were at 2, 6 for our original center, we want to get to 0, 0. Let's take everything and subtract it by 2 and subtract it by 6. We get to 0, 0. So with -3, 7, let's take those points and subtract it by 2 and subtract that by 6. Now we're at the point -5, 1. Okay, so that is that point right there. Now we're at the point -5, 1, and now we can use the scale factor of 2, and that will properly put us over to this designed point. So let's take -5, 1 and multiply them both by 2. -5 times 2 is -10. I'll just do it over here. -5 times 2, -6 times 1. So -5 times 2 is -10. -6 times 1 is -6. I'm sorry, I shouldn't have -6. I was looking at that. I should have 1. Let's do that again. -5, pretend that's times. -5 times 2 and 1 times 2. I don't know why I said times 1. So -5 times 2 is -10. 1 times 2 is 2. So our transformed image is the point 10, 2 right there. But we're not finished because, remember, we originally started up here. So now we have to take everything and revert back to our center. So let's add 2 again, and let's add 6 again to everything. So now our center is back at 2, 6. And our transformed image, let's go ahead and let's add 2 to it. I'll do it over here. -10, 2. Let's add 2 to the x and add 6 to the y. And now we're at -8 and 8. So our transformed image should be at -8, 8 right there. So going back, if I actually went back and placed all these points back in, there's that one, and that one. Let's go back and bring the center back to where it should be. Add 2 in x, add 6 in y, and boom, we're right at that point. See that? Add 2, add 6. So that's a proper dilation that's off the center. You have to treat it like it's at the origin so you can get a proper scale factor, and then you have to bring it back to its original center. So it involves a translation as well. Okay, everything can also be done with matrices. What if you have multiple points like a triangle here? Let's go ahead and actually label these. Let's call this A, B, and C. We have triangle A, B, and C at the points x1, y1, x2, y2, x3, y3. I know you guys don't like looking at letters, but here's how we got to do it here. So our final locations here, if we multiply it by a scalar factor, if they're enlarged or reduced by a scale factor k, here's a rule for matrices. You can take a scale factor, some constant number, and if you multiply it by a matrix, you multiply it by all the entries. So you'll k times x1, k times x2, k times x3, etc., etc., etc. Okay, so you just take that 1k value, multiply it by all of them. Whereas adding, you have to make sure you have a 2 by 3 matrix like this one, or 3 by 2, or whichever one it is. Okay, here's an example where I'd like you to use matrices, for instance. So I have PZG. P is at 2, 0. In fact, let me actually draw out my matrix to start off. PZG. P is at 2, 0. Remember, these are my x's. These are my y's. I'll put them over here. X, y. Z is negative 1 and 1/2. G is at 1, negative 2. Let's use scalar multiplication to find the image of triangle PZG for a dilation with center at 0, 0. So if it's at 0, 0, that's awesome. We don't need to do any translation first. We just need to multiply. And scale factor 3, draw the enlargement. So I have the scale factor 3. I want to multiply it by every entry in this matrix to get my transformed matrix. So this will equal P prime, Z prime, G prime. So let's go ahead and just take all of these values and multiply them all by 3. So we have 3 times 2 for the first entry, that's 6. 3 times 0 is 0. 3 times negative 1 is negative 3. 3 times 1/2 is 3/2. 3 times 1 is 3. And 3 times negative 2 is negative 6. So here are the coordinate points for my enlarged triangle. Remember, it's enlarged 3 times, scale factor of 3. So let's go ahead and plot these. P is at 6, 0, right here, or P prime. Z prime is at negative 3 and 3/2. 3/2 is the same as 1 and 1/2. And you always want to double check this and see if it all makes sense. You know, does that look correct? Sorry for that weird looking Z. And G prime is at 3, negative 6. And together, I think I actually have a triangle underneath this. I'll just go ahead and delete it. Together, they all form that right there. That triangle is enlarged 3 times from this center. So if it's enlarged from a different center, here, let's go back to this original triangle way back here. Where did we enlarge this from? We enlarged this from the center A. I mean, A was our center. This is where we enlarged from. If we enlarged it from here, for instance, it would have grown outward like that. No, I'm sorry. If we did it from here, it would have grown outward like that, etc. Okay, so we got through that. Okay, and actually that's it. Summary: if the enlargement scale factor from ABCD to A prime, B prime, C prime, D prime is 3, and the enlargement scale from ABCD to A double prime, the double primes is 6. What is the enlargement scale factor from ABC? It's from the primes to the double primes. So if this is 3 times larger than the original image, and this one is 6 times larger than the original image, from here to here, this one should be 2 times larger than that. You just do 6 divided by 3. Oh, don't know what's going on there. But you just do 6 divided by 3, and you end up getting the proper... Whoa. I don't know where my mouse is. There it is. You end up getting the proper scale factor. Okay. Your homework is to do 12, 7, and all these numbers. Don't do 11 and 13. Do this odd. And these and all of these, not the odds, but all of those in 65A. Chapter review, which is due Friday, May 3rd. I will go ahead and I'm going to try and start to do a solution thing. Perhaps starting tonight. That would be awesome if I started it up. You guys go ahead and, if you finish this and you finish it early, go ahead and start doing these. This covers kind of all the different problems in these sections here from 1 to 7 and should be able to help you out for the test.